Hi, today I will be talking about my second capstone project. The dataset I use for this project is the melanoma cancer image dataset, which is available on Kaggle as shown here. It contains around 14,000 images of melanoma images. Okay, now let's switch to my Jupyter notebook. Okay, so first I'm going to install some library, and then I'm going to load the image part into a pandas data frame. You can see that the number of negative and positive samples are about the same, so we do not need to deal with class imbalance here. Next, I'm going to load a pre-trained model. The first model I will try is the data efficient image transformers from Facebook Research. It is a type of vision transformer architecture that has gained popularity recently, but it is a much smaller model than the original vision transformer model. Okay, so this is the architecture of the data efficient image transformer model. And next, I'm going to freeze all the weights on all layers, and then I'll replace the classification head of this model with a new dense layer with 2 units. Even though this is a binary classification problem, we want to have 2 units with a softmax activation because we will need it for visualization later. Okay, so this is the summary of the model. As you can see, all the layers are frozen, and only the classification head is trainable. So the number of trainable parameters is only 1500. Next, I'm going to define some code for data loading and model training. This is a standard PyTorch code, so I'm not going to go into the details for this. Then I'm going to train the model for about 20 epochs first, just the classification head, and the accuracy I get is about 89%. So the next step is to fine-tune some more layers. So for this, I'm going to unfreeze the last block of this network. And now if you see, we have about 7 million parameters to fine-tune. Okay, so I'll start fine-tuning from this last block until the end of the network. And then I'm going to train for 50 epochs more, but using smaller learning rates so that the weight doesn't change too quickly. Okay, and the final accuracy we get is 92.9%. Okay, so that's for the first vision transformer model. Okay, the next thing I want to do is to repeat the same step above, but with a convolutional neural network instead. So the network I chose was the ConvNext based model, because it has about the same number of parameters as the vision transformer model above. Okay, so we do the same thing. First we freeze the layers, and then switch the classification head. So for the first step, the number of trainable parameter is only 2000, and then do the same thing, and the accuracy we get from this is about 90%. After that, I'm going to fine-tune the last block of this network, and it contains around 8 million parameters. So yeah, do the same thing, fine-tune as above, and now the accuracy is about 93%. Okay, so now we have 2 pretty good network with 93% accuracy, but what I want to do next is to look at which part of the image that these networks pay attention to when they are making decisions. So to do that, I'm going to use a library called Grad-CAM, PyTorch Grad-CAM. And I randomly select 10 images for each class and use this code for visualization. And you can see that, yeah, so the red area is where the network pay attention most when making decision. So the second column here is from the vision transformer model, and the last column is from the convolutional model. And you can see that for the vision transformer model, the area of image that it pay attention to is all over the image. But for the convolutional model, it's more centric and like on the correct spot. Yeah, so even though both networks have about the same accuracy, I would say that I'm more confident with the convolutional neural network, because from this visualization, it seems to pay attention on the correct spot. Yep, and that wraps up my second project.